Okay, I'm gonna start on the DevOps infrastructure. So introduction, what are DevOps tools? So DevOps tools, I've gone through this in a couple tutorials before, but it's a combination of development and operations. So what we're basically doing is we're setting up tool chains that can automate tasks in order to improve our development cycle. So why do we need those tools? Like why is this even necessary? So it helps with faster deployment, faster development. What it really does is it really helps stabilize our code base into like everyone's on top of the same code base. We're able to figure out who made a feature change, where it happens. It makes it a little easier to collaborate and make sure what we're running is the correct version of what we're running. So that development operation tools help streamline this, reduce the amount of bugs and errors that we're going to get when we're doing a lot of collaboration. Another thing is scale and consistency. So the same infrastructure or DevOps setup, we can scale to many different systems, robots, without changing any of the setup. So it's literally just deploying a different robot or in a different system. So what kind of tools do we have in the lab right now? So we have a couple of things set up. Well, you guys already know we have the cluster Slurm set up. So we have the cluster. It's basically a couple of server nodes that we have in CMU, and we're using something called Slurm as a resource manager that lets us access resources on these cluster nodes. And another new tool that we just got, we're using Azure Cloud. So that, in contrast to a cluster, Cloud again runs on Microsoft servers, and we can access this. We have subscriptions, and we can. What I'm going to get through in this tutorial is we're going to use something called infrastructure as code, Terraform files. That's going to show you how to set up your infrastructure systems through files, through config files, rather than manually setting this up. Other things that we have available is containerization. Everyone's probably familiar with Docker. If not, that's okay. I'm going to go over that too. So we have Docker, Docker Compose, and Docker Context, and a lot more Docker tools and their toolkit available. So this is available on the cluster already. On Azure and VMs and localhost, you have to install some of these tools. So a lot of these tools you have to install, minus the system tools, obviously, like the systems. But a lot of the containerization tools you have to install, pick and choose which ones you want. Other things that we have going as well is orchestration deployment. So by that, we have something called Ansible tools, and we have custom deployer scripts. I'll get to what all this means, but Ansible tools is basically, it's a configuration management. It's a lot of scripts that you write configs for different systems, and it just easily deploys all these install and configurations on these different systems. And deployer is the deployer scripts on contrast to Ansible, which is just installs, which you can get into deployment of code. The deployer scripts is another aggregation of command line bash commands that you're going to run on systems. So let's say you want 10 bash commands to run. It's going to automate this for you. You can run on different system, kind of like what Ansible does, but just more tailored towards bash commands specifically. Continuous integration, I've gone over that previously, but I'm going to go over it again. We have Jenkins and automated CI server running on Perceptron. It's not running on Azure right now. It's on my to-do list for Subti, but we want basically what automated testing and CI does is once you have your wonderful system set up, you're going to want to, if you get to that stage, build, compile, automated test on every single Git push or commit so you can verify that you haven't broken anything and everything still works well. And it's a really handy tool to have once you're at that latent stage of development to verify everything's still working. So those are tools that we have currently in the lab. Other popular tools that you see outside that are very popular are stuff like Kubernetes, OpenShift, and Grafana. They're a lot more heavyweight tools. We're getting over the fact using with custom deployer, which is a lighter weight version of this, so we don't need these heavyweight tools unless the lab is interested in the future works. But right now, we don't have it for a use case. Going to continue. So going down the pipeline, what DevOps and this, what are these tool chains? Where is it? Where does it happen? What tools and where did they come in place? So there's a couple of things that we have to consider in our development cycle. We have our coding cycle or coding timeline. So we do code development, and we're going to have to want to do source code management. So that's our version control, Git and Bitbucket. Why? Because we have a lot of collaborations with a lot of students. So we're going to want to make sure when we do Git merges, we're not, when we're doing a lot of code changes, we're not going to want to break our code. We don't want to introduce new bugs because of collaboration tools and conflicts and stuff like that. We want to reduce the amount of extra added bugs that come into place when collaborating with one another. So that's what Git helps with. We also have style guides and linters. So style guides, something you enforce more, say, then it's an automated thing. It's a style guide. I'll get into what I mean by that, but it helps, again, reduce the amount of bugs that you're introducing pre-running code. Then we get into the building step. So the building step, you guys are already aware of, Catkin. We already have a Catkin build system with ROS, so that allows us to build code in whatever order we want, sourcing whatever we want. As well, continuous integration helps automate that as well. So then finally, where are we building and where exactly building? We're building on systems, obviously cloud, cluster, and robots as well. Forgot to put that in there. So we're going to want to run, deploy, and build, do the same operations on all our different systems, make that as smooth and easy as possible. But with systems, we have to have a lot of configurations. And with configuration, we're going to want to have configuration management infrastructure. So they call, online it's called something called infrastructure as code. I'm not sure exactly if all these categories, all these tools fall into that category, but basically Docker, Terraform, Ansible definitely does, deployer, etc., and tools like that. So keep going down the pipeline. Deployment, once we have our systems configured, everything's nice and systems look good, we're going to want to deploy our code to the system. So that is where we get into the heavy duty tools, Kubernetes, OpenShift. But in our case, what we're doing right now is using a lightweight deployer scripts that just deploys the code to all our different systems automated. Then we get into testing. So once we have everything ready, we're going to want to test this in many places, simulations. We run simulation tests, integration tests, running everything together, obviously unit tests as well. And then finally, once we deploy on the robots, we're going to run the hardware tests as well. So as long as these are all consistent, we know we have a good running system. Some things that we're not doing, well, at least in the projects I'm on, we're not doing packaging and releasing yet, artifact packaging. So there's something called CPAC. You can create also dev packages and stuff. So you don't want to release the source code. You just want to release binaries. You can do that as well. There's release automation. You can get CI to do this for you as well. And then monitoring. So some things, there's two, I guess, layers to this. Code monitoring. So once you have your code runtime, you're going to want to optimize, figure out if you have memory leaks, synchronization errors, et cetera, et cetera. You can use the usual grind tools, val grind, hell grind, cache grind tools to see your performance analysis of your code running. But besides code performance optimizations, you're going to also want to do performance monitoring on your system. So you're going to want to see, are your systems running? Are you running all your Docker containers? Running on all the network's all up, et cetera. Your system's up, they're communicating, you're getting feedback. You want to do that kind of monitoring. So a lot of heavyweight tools like Grafana that do that. For us, we just see if we're getting a TMUX session. That's our lightweight monitoring tools right now. So yeah, that's the pipeline. I'm going to be going down that. So going down the tool chain, I'm going to get into what a lot of people are very familiar with, but coding management. Collaborative development, we're going to want version control management tools because we need to reduce the amount of bugs that come in with our code collaboration. We don't want to introduce a new bug because we screwed up a merge or something went wrong. We don't want to do that. We want to reduce the amount of stuff, bugs that come in this way. So tools that we have available, Git, we're already using Bitbucket, which is our UI for the Git. There's GitLab and there's other servers available. We can also have a private server as well, but right now we're using the cloud one. Bitbucket, that's a private, but it's not on our server. But there are a lot of options there. The problem with a lot of these tools is there's a big learning curve to a lot of these tools. So I know Git, when someone's new to it, I keep hearing, I don't know what to do, what's going on in the history. There are a lot of things you need to know, what a push, pull, merging, because you need to know what kind of conflict you're having, when you need to merge and pull, and what commands you need to do. Why do I need to merge if I have a conflict? What does that mean? And when do I rebasing? What is cherry pick and stuff like what? There's a lot of things you need to do, and that's just the basic levels of Git, let alone going a little bit more complicated than that. So a lot of all DevOps tools, there is going to be a learning curve, and there's trade-offs if you want to go down that road, if you need such tools, or if you don't, and how lightweight or heavyweight you do need to go. So, but Git, I think it's a pretty good tool to use, conversing to SVN, which I do prefer Git. But the next theme of code-base management is we want to have also to consider code-base organization. So a lot of the times in projects, we've discussed what kind of code base organization we want. Do we want one monorepo? Do we want multi-repos? Is there a hybrid version? Like, we want to have everyone develop independently, but we want to make it as easy as possible. But monorepos, it's all in one place, but multi-repos you can develop independently. There are a lot of trade-offs you have to come up with, and if you add more layers like ROS installs or submodules, you're going to get more complicated and more things you're going to need to learn in it as well. So you're going to need to figure out where you're going to break the line and trade off, and how many levels you're going to go and which tools you want to go with. So in different projects right now, in Sub2, for example, we're switched from ROS install submodules. Again, both are great options. And finally, we have style guides and linters. So these are things that you do pre-running your code. So these are static analysis checks that maybe you can see on visual inspection, or with style guides and linters, bugs that can occur before you start running. So maybe it might help, like Google style guide might be something you can enforce. Will people stick to it? The good thing about it would maybe be like you're used to that style and everyone knows to find maybe bugs easier, but maybe no one wants to conform to that style because it's not, they're not comfortable with it. But I suggest taking a look at some of these options. It's not a bad habit to get into practice, to have good styles, and just to have clean code in general. Okay. So let's gone through coding, organization management. Now, some really quick, brief tutorials. I'm going to do a really quick tutorial on Git in case there are new users to Git. So in Git, you have two paradigms, merging and rebasing. Besides the pull, push, cherry pick, the main difficulties I find with users is merge and rebase. What is one doing, what's better, and what's why, which one, and it's confusing. So left-hand side, we have feature branch and a master branch. So your master branch is 2 commits blue, and then the feature branch is 3 commits. Different paths, so you have different commits. So you're going to want to merge them together. So on the right-hand side is called the git merge, and what it does is it creates a new commit, the last one that you see with the circle, and that dash in the middle means that you're making a new commit. And what happens is, why is there a dash, is because when you do a git merge, Git prompts you need to solve all your conflicts between these two paths. So that's why you have that new commit, because that's where you're going to solve these merge conflicts. So yeah, that's what happens on a git merge. But what is so bad and ugly about the commit compared to rebasing, sorry, I can go back. What's not good about merging is you get that extra commit, which can get really ugly in history. So you have those two paths, and you see that in the Git history. Imagine you have like 5 feature branches. You might get lost reading the history, and you're not going to know why something happened, or like you will know, but it's going to be hard to look at just from a visual standpoint. So the alternative to that is Git rebasing. So the left-hand side is same as before, feature and master branches, but the right-hand side, what happens is you're basically propagating all the feature commits forward from or onto the master branch. So on the right-hand side, you see the circles are added, like from the left-hand side, but you see the middle dashes inside. And what that means and indicates, like the previous one, is you're getting a new commit where you're going to solve Git conflicts as well. So you're propagating, say, the first commit here, but you might have a conflict with this. You're going to need to solve that. And same with this one and this one, and you're solving clips along the way as you're propagating each commit onto. So you're propagating each commit of these onto the master branch. And you have this clean history of a single stream or a single path in your Git history. Why is that advantage to merging? Again, you don't get that extra commit like previously. Here, it's just a lot cleaner and simple to visually inspect. But the problem is with Git merges, and what's different with rebasing is you don't really necessarily know where a merge occurred. I mean, you can kind of look in the history and kind of guess at it, maybe. But here it's a lot more easier to see. I know where the merge happened. I know where the feature got merged. And the advantage of that is you can revert that merge really quickly. So here you have to go one by one of each commit, which can get pretty messy in some sense. But it depends on what you want to do and what your style is. I think this as well, maybe we can have like a group lab chat as well, what people like to prefer, but everyone has their reasons. Personally, I like rebasing and merging on pull requests, but that might be a bad idea. So it's something definitely we should discuss. But third part, to continue on this paradigm, the last one about Git paradigms, you have interactive rebasing. So what that means is continuing on rebasing, you're putting commits onto the master branch, but the difference is, as you see, you have here 3 commits and now you have 2. Interactive rebasing lets you squash 2 commits into 1 commit. So I use this a lot because I have a lot of messy commits while I'm developing, and when I'm ready to merge my feature branch to master, I want to go back in the history and edit some of my old commits, squash them to make it a little cleaner. You can lose, you might conflict, you might cause problems for other people. If you do this cleanly enough, you might be able, and you do pull requests nicely enough, you're going to be able to kind of keep a clean history, as long as you be careful not to overwrite any commits previously. Again, it can be difficult to use, but if you have a lot of commits and you have messy history, it's a good tool to learn. That's with Git, the paradigms, and please read more. Please read more on the Atlassian tutorials. There's a lot more Git tutorials on this. This is just a really quick tutorial on this. But to continue with tool chains on Git, as I mentioned before, with multi-repos, we have ROS installs, WS tool, and we have some modules. Right now in sub-T, we transferred over to some module from ROS install. Both are really good tools on their own reasons. Some modules, we chose it as a new contrast idea. One of the advantages of some modules is you're continuing to use the Git API, so it's Git some module. You're not learning another tool, but again, you have the takeaway that you have to learn new commands, Git some module, add-in, etc. So I highly suggest, these are just the example tutorials. I wrote a wiki here online. It's on the infrastructure which I'll get into later. Please go through with more details with some modules. They're all GIFs and some examples I have. Some modules online. If you guys are interested in learning about that, there's some more tutorials. Please take a look at that. I don't want to get into many details on this. That was our code management setup and discussion. Now I'm going to keep going down tool chain, talk about systems. So by systems, as in what we have in our air lab right now, besides the robots, we have the cluster, which, well, you already know. The cluster is a set of servers available for users to run batch simulations, development, or other operations they want on our internal server nodes. The cluster, you SSH into a head node called Perceptron, and our cluster is managed by a workload manager called Slurm. Slurm allows basically users and us as admins to to manage the resources we get to users. So like, you can request like a GPU or how much CPU, so we're not overloading. So like, we don't have one person taking over all the entire node. We can just nicely distribute the resources between all users. So Slurm is a really handy tool that lets us do that as an API that you can access resources. But besides accessing resources, Slurm also provides a framework API for showing monitoring tasks, starting and executing, and in parallel as well. So continuing with Slurm, what exactly nodes and what resources we have. So as I mentioned, we have Perceptron, which is our head node. So as a user, you SSH into this node. And then once you're on Perceptron, you can only access the nodes through Slurm. You can't access it through SSH, but you can access this through a Slurm bin bash interactive run. But before I get into that, the 3 storage servers we call storage nodes are Perceptron, Flex, and Boxy. So this is where we store our data sets. They have a lot of compute, 24 times 4 terabyte disk, 18 times 16 memory, DDR4, and Intel processors, 8 core, 16 threads. I'm not going to go into details, but the contrast to the storage servers is you have the compute servers, Bender, Clients, and Roberto. They have the GPU, the GeForce 10Xs. So you're definitely going to want to do your computation there as well. But besides the GPUs that are on our compute nodes, we have another server called NVIDIA DGX1. If Calculon is on, I highly suggest, I'm going to double check this after the meeting, highly suggest to please use NVIDIA Calculon as much as you want, and please let me know when it goes down or if there are any issues, because it's a good resource to have, and I think you guys would benefit a lot from using it if we use it a lot more. Those are resources. Some Slurm API, again, look at the other cluster slides, but some really quick tidbits. Slurm provides the commands to interact with the cluster. So sinfo gives you an overview of the nodes, if they're down or up. And then you have SQ, which tells you how many jobs or resources are allocated on a node. So right there, you can see sinfo, you see Calculon is down. I'm not sure if Calculon Slurm is able to register that. I will double check this. But mix or idle, that means you're ready. A mix might be in use, etc. So as queue, this is where you can see your job running on a node. So what I mean by a job, Slurm requires you to execute jobs onto these nodes. So by that, I mean, there's two ways you can do it, something called an srun and something called an sbatch. So an srun is an interactive batch session. So in this example, you SSH onto Perceptron, then you request a node with srun, request one of the nodes, and then you request a bin bash shell session. Obviously request all the resources, but this is basically your spoofing of SSHing to the node. So this is how you're going to get onto the nodes. You don't have to run bin bash. You can run your own execution command or script or something like that. But these are some examples of other, for like, let's say on Flexa or Calcon, you have different, a little bit of different syntax, but you can request compute or GPU, etc. So that's interactive srun of requesting a job. But then you have batch jobs. So batch jobs are in essence the same as srun. You have your options, but they're just right now what you're doing is you're writing a file, and your file you're representing these options as with this keyword sbatch. Make sure to keep the hashtag, and you're just listing these options like as you do in srun. And what this does is you're not getting real-time output on your screen of the results of your sbatch job. You're getting the output in a log file if you choose to do it like that. And then once you have these setups done, you're going to have your commands running. You're going to write your commands here, and just like srun, it's going to run these commands on one of the nodes that you specify of these resources. And then once you're done, you submit sbatch and submit, and I can't read because there you go, sbatch submit.s, and that's going to run your batch script in the background. So those are srun and sbatch. That's how you get access to the nodes. So we have our Git, our code management tools. We have our system. Now where we're going to run it, we know we're going to run it on our node, but the problem is we don't want 10, 20 users running the same code, running code on the same resource. So for example, we don't want them installing Python 2, Python 3 libraries. That's conflicts with other people. We want to have users have their isolated environment where they can run code and not conflict with anyone else. And this is where Docker comes into place. I know a lot of people are already aware of Docker, but just to summarize, Docker provides the ability to package and run applications in an isolated environment, and this is called a Docker container. So Docker uses kernel features like cgroups and namespaces to isolate the processes, and then you can run these containers simultaneously on a given host without conflicting anyone else, and they're lightweight, so you don't have a VM emulator. They're lightweight, directly in the kernel, so it's passed through, and you're not going to have any latency or performance hits with using Docker if you correctly set up Docker. So there is a caveat on Docker performance. I mentioned this before, but please take a look at this. Please take a look at this. IBM did a discussion on performance comparison virtual machines, Linux, and native, and they found what options of Docker give you best performance, as in does anything slow it down. And what they found was if you volume mount and use the network host, you're going to have the closest to native runtime, because if you don't use the host network and you come up with your own Docker virtual network, you're going to have that added latency there. So I highly suggest using the host network, as well as volume mounting. So what that does is if you put your code directly or something directly in the image, you're going to have to copy and write the layers. Once the first time it's accessed, you need to transfer the top layer of the Docker image, and you might have a little bit of performance in the beginning. If you're not sure, and I would suggest to use volume mount. You're not losing anything, and it's a good performance enhancer. But if you do want to have a packaged image with your code in it, so you don't mount code, yes, that option, put the code directly in the Docker file, is a good thing to do as well, because then you just give a Docker file and they have all the code as well, really ready in the image package. So it's give or take what you want to do, and definitely benchmark it as well if you're not sure if you're getting performance latency issues. And as well, use overlay 2 as a storage device driver. That one, I believe, is the most efficient compared to the older versions. But other terminology, just to quickly go over it, your Docker daemon. The Docker daemon is what runs on your computer. It's the service, which is basically Docker manager of your images, containers, network volumes, and all other Docker tools and setups that they have. Again, you can start and stop the service. Then you have the two main paradigms of Docker. You have your Docker images, and then you have your Docker containers. So your Docker image is where your starting point is. This is the read-only template where your instructions for creating a Docker container get written. A Docker image is written in something called a Docker file. This is on the side note that yes, you can pull Docker images from Docker hubs, but let's pretend right now that we're just writing a Docker file. So you're defining syntax and steps needed to create an image in this Docker file and run it. Each instruction in the Docker file creates a layer. So like every time you have a run command, that's a whole layer in the Docker image, and that represents changes. It's kind of, think of it kind of like as your Git commit in that sense. So when you change the Docker file in that like syntax and that run command, you're going to want to, and you rebuild the image, only that layer gets updated. Only the layers that get changed are rebuilt. So once you have that set up and you built your Docker image, you're going to want to have an instantiation of this Docker image. So your container, your Docker container, is a running instance of an image. You can create, stop, start, move, and delete Docker containers using the Docker API command line. And your container is isolated from other containers and its host machines, unless, as I mentioned before, you use the network host option to pass through the host network, which then you're not going to get completely isolated because you can talk to other containers that are on the host. But again, caveat what you want to do with that. To keep going down the Docker toolbox, Docker has a lot of tools, third-party tools, well, sorry, their tools, add-ons to the Docker, and one of those tools is Docker Compose. So why should we keep going down the Docker toolbox when one Docker file isn't enough? It gets a little messy when you have a lot of computers, a lot of robots, everyone's running a different setup, perception versus planning, et cetera, and you're going to want to have different Docker files, different network setups, because different robots, different computers. You're going to want to organize this. What tool does Docker have? Well, that's Docker Compose. It's a YAML file. Again, all these are config files in DevOps. Docker Compose YAML file, which you see on the bottom right, is where you define you're running your multi-container Docker services. So your Docker service, think of that as your app. So that's where you define your image name, your build context. So I haven't mentioned it, but Docker build context is important to know about. Basically, when you build a Docker image, you want to copy files into the image. Let's say you want to copy some kind of dev file. Your build context is, let's think of it as the workspace of the Docker image build. So that's what Docker image build sees. So if your workspace is, let's say, your home directory, it's going to see all the files in the home directory, and you can do Docker copy syntax in the Docker file to copy packages from your local host into the Docker image. So that's your build context, and it's very handy if you have different build workspaces over different setups. So let's say UAB and UGB, you can have different build contexts, which is really nice. And then to keep going, Docker context offers a lot of tags or syntax. You can have environment variables and a container ports that are open, or entry point command. So when your Docker container starts, this is the command that gets run. In Sub 2, we're doing something a little different. We're not dealing with command, we're dealing with entry point files in the Docker file, which is a lot nicer because you can specify a full bash script instead of just a single command, but depends on what you want to do. So another tool before I go further down, something called Docker Context. So I wrote more wiki page explanation on Docker Context. Please take a look if you guys are interested on this. So Docker Context, I'm mentioning it because it's if you start getting into the Azure setup or more nodes and clusters, you're going to want to, if you don't want to SSH into everything, you can use Docker Context to switch which Docker daemon you're looking at. So if you say Docker Context switch UGB, one, you're going to, when you do Docker PS, you're going to see the containers that are on the UGB. So you're just reducing the SSH command between. It's maybe not completely the most handiest thing, but I sometimes use it because I don't want to SSH all the time. So it's I guess one step before using Docker Swarm or Kubernetes or a full Swarm kind of a setup. So if you want, take a look at that. I wrote some instructions if people are interested. So anyone have questions about Docker before I go to Azure?
Hey, Kat.
Yep.
I'm still a little confused about the function of Docker Compose.
Okay.
Can you explain it again?
Yes. Let me show you. Maybe it's better to show you a proper Compose file. I'll show you that. Maybe it's a little easier to see. Okay. Can you see the screen?
Yes.
Okay. So this is a Docker Compose file on the left-hand side. This is first update. So what we have is something, we have something called services. These are services. And as you see here, these are things that I'm mounting devices for an ARM Docker image. And then I'm mounting vaults. You know how in Docker, when you create a container, you mount, you can set up devices and you can mount volumes. You can do that in Docker Compose right away. And then what you do is, what I do here is, if I change this to base, what this is my right-hand side. So I'm nesting two Docker Compose files. Why am I doing that? So this has my base setup, which has, let's say if I'm using ARM or I'm using non-GPU or if I'm using an x86 GPU, I'm gonna pick which one I want to use. So I can easily switch out which one I want. And then the base has its own environment variable setup and its own setup, network host, stuff like that. And then I keep layering and layering as much as I want. So I say now there's an Azure one which extends up the base. So if I put my final, so this is the base level. Then I have my final level, my Docker Compose on the right-hand side. This is where my Docker image gets created. This is my build context. This is the Docker file that gets built. And this is the Docker container name that gets created. So this Azure, this is the service, so it extends the left-hand side one. So all these configs, and this Azure extends this config, and this one extends either one of these three. So you're extending configs polymorphism depending on what kind of system you're having. So I don't need to write like 10 Docker images with specific configs. I can just layer and nest which kind of config I want, and I'm just telling on my command line I want this instantiated. So that's going to get me that image, that container with all these specific configs that I want. It gets a little complicated on my setup because I'm specifically trying to choose. I'm going overboard with some variables because I want to switch between which version I have, but we're not going to do that in this tutorial. But the point of Compose is you can nest configurations and you just call this one setup, which is going to have everything for your array set up in the previous one. So I can easily switch out Azure with robots, which has different IPs and different host-like environment variables. I don't need to have everything the same. Like it's easier to maintain in that sense. And because we have a lot of different styles, we have base station, perception, which are all different. They all have different Docker files. They have different entry points. They're expecting different. So when you source your CAC and workspace, I'm going to want to source this one in perception, but in base station, I want to source a different one. So it's configurable and it's nice, but there's a lot of syntax that you have to go. So I don't know if that answers your question.
As long as I can understand, so this Docker Compose helps us to quickly create images, or
it helps you nest configurations for different images. So
okay.
like I can switch configurations for an image. So if perception has to have the NVIDIA drivers mounted, my perception compose is going to set that one, but the base station one isn't going to use that one. But I don't have to write it every single time when I do Docker run. I have it in my compose file. It's already set up for me.
So if I understand correctly, like on the left side, you have all the base configurations that are common across multiple instances. Okay.
Yes. Yes, exactly. And then the right-hand side just specifies the Docker file, the image name, and then your container name and your entry points. And then the right-hand side is what you're running on the command line. You're saying Docker Compose instantiate this service, and it's going to nest all of your base stuff. If it's still not clear, let me know. I can keep explaining it a different way. I guess another useful concept of the Docker Compose is we're version controlling all these configurations. I don't need to tell a user on a README what they need to do. I know what it does and we know it works. So that's another configuration advantage to Compose.
Yeah, like what's nice about like this with the sub-T setup is the same exact environment is set up on Azure, is set up on the robots,
yes.
is set up on your dev machine. Your environment is your code, is code now. And so then you don't have the situation where people are like, it works on my machine, but it doesn't work in Azure and it doesn't work on the robot, or it only works on the robot, right?
Yeah.
That should never happen now because the environment is set up the same exactly everywhere. And just like one more quick point is like the whole point of the Docker Compose is to basically let you do what you can do with like individual Docker files and Docker containers, but just be able to do it on a larger scale with multiple Docker containers, multiple Docker files, and have, you know, this whole nested configuration set up. So you don't have to like create a whole bunch of extra tooling to say like, oh, I need to launch 10 different things. No, you just create one Docker file or one Docker Compose configuration, and then it just like it launches all your images, all your containers.
That's exactly that. That's the whole point. Like, yeah, maybe in like a single Docker file case, you can't really notice the advantage, but when you're managing 10 robots on 3 different, it just gets messy to tell everyone how to, with all these configs. You want to know what you're running, basically. Okay, so continuing down the toolbox, we have our Git, we have our cluster, we have our Docker. We've got that set up locally or on the cluster, but now we have another tool available. We have the cloud, Azure Cloud specifically. And you can, there's 2 different, I guess, ways you can look at this. You can take Azure, the portal, and create your own setup and simulation how you want it, custom your way, and that's fine using GUI tools. That is completely a good option and a good way to do this for development in your case. The use case that we're trying to solve, or at least trying to help out with in sub-T, is we have a lot of students that we need to run a whole system setup, but the full system stack. So having everyone manually write everything by themselves, it's going to be hard to make sure everyone's running the same version of the code, the same system setup, that they haven't, it doesn't work for them, they haven't updated. It's very difficult to manage a lot of people running the same simulation setup. We want to make sure that what we're running works the same for everyone, that everyone's running the same thing, and that we're able to maintain this revert, see features or bugs right away when they happen. And with that, with those questions and concerns in mind, you have to kind of try out maybe like an infrastructure setup for Azure. And that's what you see in this diagram. It's pretty simple as a flow chart. What that sense is, we had to add in a couple more tools to get our whole cloud infrastructure ready and up and running. For, let's say in our case, was for sub-T. So we want, on the right-hand side, if you see, we want, let's say, 8 VMs or 10 VMs running the code with everything installed, Docker, et cetera, with simulation, everyone talking to each other, and we want to see sub-T running with artifact detection and everything happening. And in the future case, we will want continuous integration to always tell us it's broken or it's working. But how do you get there? What exactly it takes into getting there? Again, what I said, we want this version control. This is something called infrastructure as code. So on the left-hand side, I'm going to go through the flow chart. Left-hand side is where you see your local group of your project users. So user 1 right here is going to set up on their laptop setup of, let's say, for example, sub-T. So what happens is you go down the flow chart is you're going to clone your repo. So you're going to clone your repo, some modules, et cetera, however you do it. Once installed, clone the repo, and then what happens next is you're going to want to install packages, configurations on your local host to get your system up and running. So you can do this manually, which everyone does through README, which is also a good option. Another option that we took into account for Sub-T is we're going to use something called Ansible scripts. They are, I believe, YAML scripts, which basically lists a specific syntax that Ansible, the company, is requiring that will tell you install this package, these packages on this host, and I'll get into that a little bit later. But basically, it will install system dependencies and set up configurations on your system. That's what Ansible does. And then going down the flowchart, we're going to get something called Terraform. So Terraform, now that we have our system packages installed using Ansible, we have our Git repo, we're going to want to create this on the right-hand side. Again, we can do it manually. What we're trying in Sub-T is to use this infrastructure as code. It's basically, we have configuration files which list VM1, VM2, VM3, all the VMs we want up, what their configurations are, what this network setup is, what the security is, and obviously the VPN connection. And storage access if you want. Perception has a different GPU. So we want this set up in config files. That's what Terraform does. And we're going to want to interact with Terraform to create this or destroy something or potentially change the configuration. So Terraform, besides being a configuration files, you're also getting a configuration management tool that will create this for you. So that's what Terraform is. So going down the flowchart, let's say we've created this. We have this all up. So we have the just VM started and the network, etc. We're keeping going down the flowchart. So again, this is your local host. This user wants to set up the whole system on their local host. So this is where we get into the compose. So what we mentioned previously is I'm going to want to have a Docker set up for the base station, for planning, SLAM, perception, etc. So I'm going to want to have different containers set up, all talk to each other, and have everything built. So you can do this manually on the command line, say Docker compose start A, B, and C. What we added is we added another tool called deployment on automated scripts, which will, the deployer, these are deployer scripts, that's what they're called. Think of these as like bash aliases. They're basically bash aliases that will say start A, start B, or start C, or build A, B, or C for you automatically, that you don't have to do it on the command line. So you don't have to remember all these commands. You just use a deployer to say local.basestation.docker.start. Again, all these aliases are custom made. This is an example, and that will create your Docker container image on your local host. So it's kind of, in some sense, a lightweight deployment Kubernetes. It's not Kubernetes at all, but it's in some cases that purpose is being fulfilled. You're deploying containers, you're deploying your code. The deployment can also build Kakin. It's basically an aggregation of bash shell commands that you run using a bash alias call. So using deployer scripts to create your system, you have it set up, you have it launched. You're going to want to, you have it set up, you're going to want to launch it with tmux. We're using tmux. There are probably other alternatives. We found that was convenient for us. tmux with Rosmon, and we're basically getting the simulation up and running on your local host. Now, once you have that set up locally, the next question is, how do we get that on Azure? Again, students and everyone in general just create the VMs manually on the portal, SSH in, and just clone there and do it manually. The problem with us is you don't want to do that manually for like 10 VMs every single time you make a change. That's going to get really difficult and annoying to just check one change. So we're going to want to automate this a little bit. So what Terraform got you the VM started. Now you're going to want to do what you did on the left-hand side, this flow. You're going to want to do the same thing on the right-hand side, but not manually by SSHing. So that's where the deployer scripts come in. The deployer scripts, what I've done here, is also going to do the same thing on this side. So you just do, instead of what you did locally, let's say local.basestation.docker.start, you're going to want to do azure.basestation.docker.start. And that deployer script, so it's basically a set of YAML files, already has it configured to know to SSH into that container, into that VM. So it's kind of, in a sense, like Ansible, but just only specifically bash commands that get aggregated. So with the deployer script, the lightweight one that we're using, it's going to set up the same thing you have on your local host on the VM for each VM. And you're doing this all from your local host. You're just running the deployer script. It automates everything. So within a few deployer script commands, you're going to have your whole system, as in all the Ansible scripts are downloaded. you're going to have your Git repo download. So the Ansible scripts on the VMs, they download the Git repo. So it installs your system dependency, downloads the Git repo, and then the deployer does Docker compose and the cat-can build. And then you have your simulation running. Right now, in our case, we're manually running the tmux sessions. This is also automated on the robots with the deployer scripts, but you can do it however you want. Besides that, again, we've connected the VMs, just a side note, to the Azure storages, where we can put data sets and you can easily, in your OS, mount the data sets and use that during testing or development. So that's a high-level overview of some of the tools that we're using for Azure with this stack. Okay. So the high-level overview I talked about, I'm just going to give a brief overview on the specifics. I'm not going to go into too many details because there are a lot of details and I don't want to bore everyone with this. But the concept is the deployer scripts, the purpose also, another purpose of that was to hide a lot of these implementation details from the user. So we don't want the user necessarily to know this setup. We want, let's say, the team lead or some other lead of a project to know how to set up, or some other person to set up. We don't want necessarily everyone to know, new users, why do I need to change this or not? No, let's just let them use one script to have everything set up. But those that do want to set up their own setup, they're going to need to know a couple of syntax of the different tools that we're using, if you want to use the same tools. But to summarize a little bit again, but Terraform is a tool for building, changing, and version controlling the cloud infrastructure. It's infrastructure is cloud, you're version controlling your cloud infrastructure. These configuration files, they describe the Azure resources. Terraform works also with Google Cloud and AWS. And in our case, we're using Azure. So it describes, if you see in this case, our virtual machine and how we set up the, let's say, UGB. And this YAML, in this configuration file, you can see I'm overloading a lot with variables. So what we like to do is I like to have like variables with, say, like default host names, and I just append like another host name if it's UG1. Or a specific, I want every VM to have a username. So you can use variable names. It's really convenient. You can set up however you want. So the nice thing also about Terraform, if you change one of these configs and you use the Terraform command line tool to recreate or update your Azure cloud, it's just going to update the change. It's not going to destroy the entire system and then recreate all the VMs. It's just going to update that one part of that VM. So that's also really nice. I think it kind of got, I don't know, to me it seems like they kind of got a feeling from Git. They have a state.state file, kind of like a .git file, so they see changes like a git diff. So kind of same essence in some sense. So yeah, Terraform helps you create, manage components, virtual machines, storage, networking, VPN, everything Azure related. They have good README and it's very well documented. There are probably other tools also available besides Terraform. This is one that we chose to use for SOT. Continuing on the toolbox of configuration management, you have Ansible. So the right-hand side is an example Ansible file. So your Terraform files, those set up your VMs to get started. But you're going to want to install stuff on your VMs. So for SOT 2, we had a lot of packages, and different VMs have different packages, so we want different things installed, obviously. So what I liked about Ansible, which really kind of drew me towards it, is this host setup. You can in Ansible have list files, and each file has a description of this host. So UGB is like a group of UGB VMs. So UGB1, I have another file saying UGB, UGB1, 2, 3. And it knows when I'm on my command line, I say Ansible build, and I say UGB1, it knows it belongs in that group, and it's going to build this for the UGB1 VM. And that UGB1 configuration file that I wrote already knows how to SSH in, has all the configuration already set up. That's really convenient. I don't need to say SSH here or anything. It's already set up in another config file. So it's really nice to plug and play different systems that you want things installed. You just say in the command line, I just want to build on UG1, it builds this on UG1. And these are example commands that get built. So let's say here, this is a bash shell command. They have specific syntax. So if you don't want to use a bash command for every single thing in Ansible, you can use their like specific syntax for like git cloning. Up to you how you want to do it. I tried out a lot of different ways, but I have a lot of different files like this. These are called playbook tasks. So just to talk about one more time, the Ansible, it's nice because it allows really nice network layering, makes it easy to deploy the same install setup on different servers. It's really nice for that. And these playbook tasks, you can easily list different playbook tasks, different files that install different things. So this is a task that installs our deploy repo for subteam, but maybe I want a task that installs Docker only or other things. I don't know, ROS, it doesn't matter. So you can easily list a lot of files, and you can have a final install file that's gonna list all the tasks that you wanna run on the VM. So that's really nice, and it's really, really configurable. That's what I really like Ansible for. So this is a custom script that we have. You won't find the README online. I'm still updating this README. What the idea behind this is if you don't want to use Kubernetes, a really high load, really complicated tool we might not necessarily want. This was a little slimmer version of deployment onto different robots. So as I mentioned before, the deployer aggregates bash commands, and then using the command line, you say deployer azure.ugv1.docker.build. I'll show you in the next example. Just to repeat again, the deployer, you have a script and you run this bash alias. These things are custom written. They're dependent on the YAML files. So the deployer, it reads these YAML files. It reads it as a tree. And then this bash alias is a single path in that tree that gets executed. So in these YAML files, you can see you have a list of bash commands. And then depending on which layer you want to go in, it's going to create that path of bash commands that it's going to run. And some of the nice components of this deploy tool, you can extend other config files. So let's say I have an extend here, I'm extending this right-hand side file. So it's basically going to take all of this and just plot it in there. So when you do azure.perception, so if I go down the tree, the path in the tree is azure.perception1, and then .gpu.kaken.build. So you keep going down that to it matches. A convenient tool of the deployer, it doesn't need to exactly match azure.perception1.perception1.gbc, the duplication. It's a regex matching, so it matches just part of it. It finds the best match of the path of the section names. So you can just give a shorthand if you don't want to write the full thing. But basically what you're getting with this is you're getting these commands to be run, then you're getting these commands to be run, and then you're going inside, this is Kaken, you're going to go SSH into your perception node, you're going to enter the Docker container, and you're going to have your .build, you're basically going to run all of this, which is your Kaken build inside the container. So it's again an aggregation of bash commands, and they're referenced using these aliases, these things. So it's been, I've been getting a lot of feedback. People are, obviously it's not obvious which alias you have available. There is like a preview command and a verbose command that show you all the available options, but I've been getting feedback, maybe like a better way to indicate what options we have. But right now, what we're doing is if you do a -p, it's going to show you all your options that are available. And a -v is going to tell you exactly which bash commands you're going to run. But yes, it's not very obvious, and there's a little bit of a learning curve. The only advantage of using this is you don't need your heavy load Kubernetes and all its configuration files switching. You just write a couple of YAML files, and you're just going to have your bash commands executed on whatever system you want. So that's the deployer. And then just to finish off, I mentioned this before, with what we have on the Perceptron is we have continuous integration Jenkins, but basically users don't need to install anything on Perceptron. Jenkins is already installed on the Perceptron. Users only need to configure their repo to use Jenkins. So again, like in the theme of all this DevOps, it's another 2 configuration files. I'll show you next. But what you get is if you are on the CMU network and you enter the Jenkins HTTP address, you're going to get this portal. And that portal is going to have a set of jobs. And what Jenkins does, I haven't mentioned, is Jenkins is just an automated way to clone your repo, to Kaken build your repo, run tests, and then just show the output on Git on your commit. So that's what it does. It's on, I guess, a later stage of development when you want to just make sure you're maintaining it correctly, or an earlier stage if you want to get feedback early, it's up to you. But it's a tool that we have available, it's up and running. Take a look if you're interested. I believe, yes, I have a proper wiki of how to use and how to set it up. So please take a look at that as well with examples. To continue with the Jenkins, just to finish it off, I mentioned that we have to set up configuration files. So because we're using Slurm on our cluster, we had to make some custom scripts that will have Jenkins talk to cluster, as in which node you want and which Docker image you want, etc. Do you want a GPU and what you want mounted. So that's a Jenkins configuration file. And then how do you tell Jenkins what to run and what gets cloned and what to do? You have, continuing what we're doing is you use the deployer script. If you see the pattern, this is the deployer YAML file. So it runs these commands and you're setting up a Jenkins configuration file that will tell you to run which part of the deployer config. So you're going to want to run build, which is going to run all of this in the build stage. And the build stage has this, and that's one of these columns that you see in Jenkins. So configurations that gets connected to your portal and eventually to Git. Yeah, it's the theme of YAMLs and config files. So just to, I might have shown this before, but just to show it again, an example of Jenkins running, I make a commit in a repo. Okay, and I push the commit, and then you're going to see the new job get created. So I already created this job. You only create it once on your new repo. Once you have it, you tell Bitbucket, a webhook, which is all in the README, to connect. So every Git push, it does this build, but you do that once. And once you have that set up, it's always going to do this. You don't have to change anything unless you're changing the build configurations or any of like stuff that you want to do in the output of Jenkins. So that is the end of the talk, I guess, discussion. Questions, I just want to finish off that I'm going to keep updating the README tutorials in more details, specific details on all the tools that I talked about. This is a bit more general, and all feedback is very welcome. I want to know, like, it doesn't work well if it does, or if it's good or not. And after questions, we're going to go into the tutorial and try to do a very slim version of what I talked about. Okay, so I'm going to do the tutorial with you guys. All the infrastructure code is in the infrastructure project on CA Stacks. So I have the top level one that you're going to see the main README is the infrastructure repo. And I'm going with submodules, so you're going to see all these other repos linked in the main repo as submodules. So you see that as that commit hash, etc. So I'm going to be updating this. Andrew and I have started adding Docker files that we think are interesting, and we want to keep adding to it. I would like if people can add to it as well. If they don't want to, that's okay too. But this is a good start if you guys are interested in this. But keep your eye on it. I'm going to be updating it often. To start, so yeah, system. I only tested on 18 before. It's at our Python 2. Unfortunately, I'm going to get that switched to Python 3 eventually. For this tutorial right now, you're going to get perception, cluster, and count because we're copying something. I have it also on Azure, so if you don't have a perception account, it's okay. We can get over it, but just let me know. And obviously, you need an Azure account. So make sure you have all that set up. So I personally do have that set up, and I'm going to skip this stuff because I'll show you anyways. I already have it set up, but basically, you're going to want to make Bitbucket keys. Okay. But basically, you're going to want to make Bitbucket keys, and you're going to want to copy this. Sorry, this one. I'll just make sure you just write that. So what that does is that's going to create your key that's going to connect your bucket account so you can clone without asking for a password. I've already done that. I hope you guys have that set up. But yeah, basically just follow that and you'll have it set up, and make sure you follow step 4 for adding your key onto your Bitbucket account. But once I finish that, I'm going to want to add that. So what happens is on SSH, it usually by default just adds the IDRSA as the default that gets sourced, or SSH-add. Bitbucket gets a different name. I'm not sure if it gets added as well. So if it doesn't, what you can do is you create a new SSH config file, and then you're going to have and basically we're going to add it to the top. You're going to add it like that, and that's going to basically every time you start your computer, it's going to source that Bitbucket SSH key. So you're always going to have SSH access to your Bitbucket repos. So it's important, please keep it in that path. I've hard-coded, unfortunately, in Ansible that path. Eventually I'll get this a little less hard-coded, but for now, please keep that SSH key hard-coded to that path for the bucket. I've done this myself, but please install the Python stuff. So just a quick caveat, I mentioned in the presentation that you're going to want to have Ansible do all this for you. Yes, I currently haven't updated Ansible for the local host install. I've only done it for the VMs. I haven't just tested it on the local host. It works for Subtia, but I haven't tested it for this tutorial. But so for now, I'm sorry, but please manually install for now. Eventually, we'll have Ansible for local host as well. I have that installed, so I'm going to keep going. Make sure that. Change that, and then okay. That just clones it. All right, so just a quick thing to show you. Some modules, because I'm using some modules, they don't get cloned by default. So keep that in mind. Oops, keep that in mind. There is nothing in these repos. So what usually you do is get some module. You're going to want to do something like that. So that is going to clone this submodule in this repo. So instead of doing that for everything, you can do a dot instead of this, you can do a dot. What I also have installed, so that's this instruction here. Please follow that. That's going to clone everything for you and also set up some configurations in your bash RC. What those configurations are is there are some scripts in the infrastructure repo, like handy bash scripts, and they just get added to your path. I'll show you what I mean. Okay. So just like that. All right. So what I mean by that, see. So that install instruction, this one, install instruction basically adds these 4 things to your bash RC. So it just adds your path, some scripts, and just adds it to the path. Why? Because we have some handy scripts here that we want to be able to use from anywhere. So that's why I did that. So please do that. And then your source bash RC, and if that does source, or if that doesn't work, please open up the terminal, and that will get it for you. That's the basic setup, just the cloning. And then I've written a README, I've written links to various READMEs of tools that this infrastructure uses. Go ahead and learn it at your own time. You can learn it right now if you want to as well, but a lot of reading, detailed syntax if you guys are interested to maintain and modify this. But yeah, it's just there if you guys want it. So now I'm going to go down the tutorial. So we're going to be doing a slim version of what we have for Subtea. Subtea is a bit more complicated, just a little bit. This one, what Subtea does, Subtea creates a VPN per user because we want a specific set of, like a specific subnet of IPs. So what we have in this tutorial is the VPN's already set up for you, and we're just going to create VMs and nothing else. The VPN setup and that virtual network setup just takes a very long time to set up, so this is a lot more convenient for this tutorial. But let me just, before we get into the Azure setup, let's just install all our tools on our local host. We need to interact with everything. So I've already got this all set up. Please follow this README. So you're going to want to install Docker Compose. This is optional if you want NVIDIA Docker. So if you're using a higher version 1903 of Docker, please don't install the NVIDIA Docker tool. Just use -GPUs instead. It's on the official documentation. Take a look. If you're using an older version, feel free to install the older version. There's some setup. So that's the NVIDIA Docker if you're interested. This is x86 as well. Some other tools, please install the Azure CLI. So just download the Azure CLI from Microsoft, and I'll go over how to verify everything in the end. But that's what basically your Azure communication, see what VMs are running. So this is different than the Terraform's different command line tool. So you have that. You can do an AZ copy as well if you want. You can copy, I believe, with Azure AZ, Azure CLI, but you can use easy copy. I've been told this is faster. I haven't done any benchmarking or looking into this, but that's also an option if you guys are interested. I've also noticed that on some storage containers, like file systems, you have to have an SAS to allow you to copy things. So yeah, keep aware of like how the syntax for this is sometimes can get tricky on that. Have your Terraform installed, so please follow this. I've also noticed with some students, they had trouble installing some things. So if you cannot do sudo apt update, please make sure you don't have broken packages. If you can install, there are alternatives like with pip install. So please let me know if it doesn't work for you. But this is just like a default base Ubuntu, it just is okay. Terraform, get that installed. Ansible, and have that installed. And then optional TeamViewer, if you want TeamViewer on your local host. So I personally, yes, I use this a lot because I TeamViewer in the VMs instead of RDP because it's a little smoother and the RDP is a little choppy, which I don't like. And then this one's a little bit smoother, which is pretty nice. The only downside is my computer has crashed a lot with TeamViewer, so up to users how they want to do it. So to verify you have your tools installed, I'm just going to go and show everyone. Please verify you have everything installed. Obviously, if you didn't install NVIDIA Docker, don't verify it, but just make sure that everything is fine. I'm just going to show everyone what mine are just to compare that. That one, that's okay. That one and that one. So another thing that you need, so these are the third-party tools that you're verifying. These are our custom scripts that you also need to verify. Obviously, source your bash RC or zish RC. And then check this compose wrapper. It's a custom script we have, and also check the deployer is up. So if you have all that ready and no errors like I do, then you're good to continue. So next steps, we're gonna want to set up our Azure setup. So I think maybe the best going way forward is just to set up first, and then I'll explain the folder structure, how this all looks like, and where these files are that I've discussed in the discussion. So right now, let's just blindly continue with the tutorial, and then I'll go a little bit more in the discussion at the end. So I'm on the Azure, I'm on this one, and then that gets me here. So it's in the Azure books module, so that's the README. What you have here, if you didn't previously install, it just says it in there as well, so you can skip that if you've installed all those tools. And then you're going to want to now create your Azure your VM. So you pick which project you want. So we're going to do the AirLab tutorial one. So there's going to be a bit to do, unfortunately. There's a bit. So I'm going to go through it because I destroyed all my VMs, and I can go through it again, and I'll let you know what I ended up doing. So that one is okay for me. I'm going to just log in. Okay, I am logged in, and then you have your Azure subscription set up. So you're going to see something like this. So that gets you connected to your Azure setup, and then you're going to want to, you have to, as a user on this configuration setup, set up a couple of variables. So once you have this printed out, your subscription ID is this one, and your tenant ID is this one. So make sure to keep in mind what that is. And what you do next is you open up your bash RC, or in my case, bash RC, and then you're going to want to add your subscription ID right there. So no quotations, nothing, just add a plain string like that. Your tenant ID, and please put your username as well. So I went over really quickly, I skipped over it. Your Azure username is the part before the @ I mean, it's your full username, but before the @ is what we're going to use for Terraform. Sorry about this. And then your Azure resource group for our tutorial, I'm going to show you here. Resource groups. So we have a couple resource groups. The one that we're using for AirLab is AirLab specific. So that's the resource group that you're going to want to list. So Azure command line requires you to specify the resource group in a couple of places. So know where to put the VMs. Yeah, please keep the default paths in the files. I'll show you that next. But yes, if you have this, good to go. please exit that, source your ZSHRC or whatever, and then let's continue. Let's keep going down. All right, so I'm going to continue. The next setup, we haven't done anything yet, so sorry. The next setup, which I already mentioned before, is we already have a public IP and a VPN already set up for our tutorial. So we don't need to create anything. We just need to connect to the Azure VPN. So what the Microsoft suggestion is for Linux is to use this third-party VPN tool called StrongSwan. Please download it. I've also had people issues with downloading like this, so let me know if it doesn't work. So download that, and then once you have that, you're going to want to create your VPN certificates, your client certificates. So what I mean by that, start to fresh. There we go. Okay, nothing in here. So this is where you're going to need Perceptron. So when you create a VPN user certificate, the user needs to download the CA certificate because the user needs to sign their user certificate with the CA certificate. So basically what you do here is, let's see. Okay, so we're going to want to go to the tutorial one that we just downloaded, and we're going to want to create our user certificate. So with that, I have a default password. I like to call it the same way as my username, cat. And then I'm going to want to do this. So this is going to create your user sign certificate. And then you're going to want to create it. So let me continue. Now that we've created our certificates, we're going to want to download the client. So Azure, for the VPN setup, has a VPN client you're going to need to download. So it's already set up with the user group. Just copy it. It's already set up as these config names. So once you've once you got the name of the zip, you're going to want to download it, and then I do that. If that command doesn't work for you, please just put that in your browser. That's going to download it for you as well, and just download it to this path that you're currently in. Once we do that, we're going to want to unzip that. Ignore these arrows; those are fine. You have the folder there, and then you're going to want to do that. You're going to go to the client download. So that's what the download client that you download from Azure VPN. And then you're gonna want to look and search for this connection keyword. So the next setup is, once we have all that in place, we're gonna want to, on our network GUI, create the VPN connection. So what we do for that is, I already have one set up, but basically what you do for that is call it whatever you want. This that you got down here, you're gonna want to copy that over here and make sure you catch the suffix as well. Everything between the VPN tags, server tags, your user certificate and your key, and then request your IP address, and that's it, and that should get you VPN. So try turning it on. If it doesn't turn off right away, then that means you set it up correctly. If it does, that means if it turns off right away, that means you haven't done something correctly. So let me know if you have trouble with this. Okay. So once we have that VPN connection already done, we're going to want to create a SSH key for the VM. So I SSH into the VM. I want to do it over SSH. So I'm currently, for now, keep with the default hardkey pass. This can be changed. What I do here is, there we go, and then I call it VM key. No passphrase on any of these keys, just so you don't get any permission errors. It's not good practice, but it's fine. And then you're going to want to, now we're done. We have our VPN, we have our VPN key certificates, we have our SSH key. Now we're ready to go back and create our VMs. Okay, so now that I'm ready to go, I want to create the VMs now. So the next part is, there's going to be some user configurations. You're going to have to personalize some things. So there's not a lot, there's just a couple things. You open up your repo, and then you're going to want to open up this specific folder. So AirLab, Azure Books, AirLab tutorial main TF. So that's that one. And then tutorial, there we go. So what you have here is you need to change the Terraform key. So that's Terraform and then the key, that file. So this is your main Terraform file that I mentioned earlier. This is your user entry point. This username, please change that to your Azure username. Like I said before, the @ symbol. Keep everything else the same, that's fine. That's what it says. And the only other edits that you can do is you can change stuff like that. If you want to just create the CPU VM, if you want to create a GPU VM as well, just change that to true. Which type of OS you want, or like users type you want, the amount of disk space you want, please keep this as the default. And this is your region, the group, the AirLab group. And then finally, this is the prefix that all the resources that you create will get. So I put the default as your username. If you don't like that, you can change that. But that's it. That's all you need to do. Once you have those configurations set up, you're good to start creating the VMs. So I'm here, and then now we get to this was the Terraform configuration files. Now we're going to interact with the configuration files. So once you do, you have to first do Terraform init on the first try. So that's going to create, I believe, Terraform. Yeah, it's going to create Terraform files. That's going to connect with the Azure Cloud setup that we have for AirLab for users group. Once you have that set up, you're going to want to do plan, Terraform plan. So what that is a dry run of your configuration. It's not going to do anything. It's just going to show you what it wants to do. Apologize for that. There you go, your virtual machine. So I've only opted to create a CPU virtual machine, and it creates your network interface and then your security group associated with the VPN. So after I've dried on it, it looks okay. 3 resources to add. I'm going to apply it, and I'm going to just create it. It's going to create it for me after it's prompted. Yes. Okay, so creation might take 5 minutes. We're only creating VMs, so it shouldn't take too long. If you ever create a custom, like your own VPN, which we're doing for Sub-T, it's gonna take at least 30 minutes. That takes a very long time to create. There we go. So that's gonna verify it, and now I want to make sure that I'm able to VPN inside. So first, what I want to do, I want to find the IPs of it. So my username. So in my case, because I use a different username for that, it's going to be this one. So I'm going to want to check, can I ping this? I'm on the VPN. Let me see. Cool. So if I can do that, let me try SSH in. So I'm SSHing using the SSH key that would be made for the VMs. Copy this, and then the private IP. So the VMs have private IPs, only the VPN connection is the public one. And try that again. All right, so now we're in the VM, so that looks fine. So we're able to access VM issues if you want to see more. Another tool, this is going to take too long to install, but you can create a RDP connection to your VM. So install this, it says on the remote, but install this on your remote. By default, the VMs don't have a password. You need to set up a password. Going down the README, the Ansible script is going to create the password for you. But right now, if you just want to show it right away, you can do it manually. And then what you can do is we have these handy scripts that's going to give you the RDP connection to your VM. It's going to take too long, so I'm not going to install it right away. So once I'm done that, that's basically your Azure setup. I'm going to keep going down. You verified on the command line tool. And then I believe I also wrote some other useful commands that you want to take a look at, like already what we went over, how to destroy your VMs specific or destroy specific groups of resources. as well as common questions and issues that you might run into. Again, a lot of this copied over from the previous tutorial. So Azure setup, we're good, that's done. I'm gonna go back to README, and now I'm gonna continue with the Ansible setup. So that's what I call robot books. You can call it whatever you want. I call it that because we're deploying to the robots. So this is gonna get you started on connecting, installing the packages on your VM. So if you don't already have this stuff installed, you can install Ansible if you don't have it already done. I already do. So then I'm gonna do my prerequisites. So the prerequisites, unfortunately, for this tutorial, we have a dynamic IP being given to us. For sub-T, we have static IP, so you can change that. Why I say it's a downside is because what I want you here on this tutorial to do is to add this to your host file. So I already added here, I believe this is now 6. Okay, so I have that. So I want you to add it to there and then ping, double check. Anyways, just keep in mind. And then the second configuration that I want you to set up is I want you to check out, look at SSH config. So if you've already done that, put your Bitbucket up there, and then I'm going to want you to add SSH configuration to accessing the VMs. So I already done it here. What this is you can give it whatever name you want to make sure you get the same host alias they give your etc. host file and your SSH key into the VMs. And the username, default username for all of the VMs of the tutorial is log. So now I do that one. Yep. That works. Cool. That's fine. And now we have access to the VMs over SSH config. So the next step is once we have that all set up, we're going to want to run the Ansible script. So make sure some bucket keys or hardcode, make sure you have that created. And then let's see if this is up. Yep. So there's another hand tool called info check SSH. It's going to tell you which SSHs are up and running. So connect this. So then we have that one connected, and then go up that finish. All right. So now we're here, and now for the Ansible scripts, you have to be in the robot books folder. It doesn't work if you do it from anywhere. It has to be in this location, specifically in the project one. So you're going to see we have install Azure, install localhost, and lots of other things here. So you want to do that. Just copy this. This is like a dry run. It's going to tell you like how the current Ansible scripts are set up to default as. Again, double check we can ping. Yes, we can. And then I'm ready to install. So what this does is this command is going to install your packages. So I'm going to just run it, and specifically running on CD one. Okay. So that's going to run and take a while to finish. So just show you on the robot books of the Ansible. So I believe I installed Azure. So what this is the top level robot books, your Ansible script. So this is up to you. There we go. Right there. So this is what I mean that you can nest different Ansible scripts. So what this does, it looks in task, it looks at robot host, and you're going to have that, and it's going to nest this. And depending on what you put in here, that's going to figure out where you're going to deploy these package installs. So by that I mean these things get defined in something called an inventory folder, and here I've defined some names with that. So I defined some names that what you saw here is what I give it on the command line. Put it in a group of airlab. So you can write airlab here if you don't want the specific name of the specific VM. Give it some more command, like some more defaults to the airlab name, and then you give it a path to an SSH Azure config. So this is not the one that you see in your tilde.ssh config. This is one you wrote manually. So what this is Ansible looks for this, which is what you get here, and finds this SSH config. This is what you put in your etc. host file, the VM key, and that's how it SSHs into the VM, and that's how you get that. So that's how that, and you can just switch, and you just change which command line servers that you want to put, and it's going to just install on that different one if you set up all your inventory files correctly. So that's that, and then there's a lot of other neat things here. These are all the you can put things in variables of what packages you installed. That's not, but this is going to take a little bit to install. So I'm not sure if I'm going to have time to do the deployment stuff, but basically when this is finished, there's a couple other parts of the README that you guys can continue with is with setting up the Docker images and the deployment examples. Okay, and then, yep, that's it. We have TeamViewer access to our VM, so can continue working on it as is, and that will give you, that's the Ansible setup. So we finished with that part of the deployment. So that was not too bad. Azure Terraform again, careful with that. And then finally, we're going to want to finish this up with deploying Docker and our tech and build on the VMs. Now, we're going to do the deploy setup. So you're going to want to set up Docker images using the deployer and the Katarina workspace using the deployer. So an example, start first with the Docker images, changing to your workspace. So an unfortunate current thing is the deployer has to work from this path. So I'm going to get that fixed so that it can work from anywhere. But for now, it's set up with that, so please be in this folder. So I was mentioning before, the deployer has like an alias keywords, and then you can use -p to preview if that exists. So another example is if I remove the last suffix, it's going to show you which other options I have. Again, you don't need to give it the full name, CPU1 Docker. You can just give, it's going to match CPU1 and then Docker. Anyways, so that's an example of the deployer books. I'll show you at the end where these are defined. But I tend to do that if I don't know what it is, and if I really don't know what it is, then I look at the YAML files. But I know it's that one, so I'm previewing it, and on the -v verbose, the -v verbose is going to show me what commands get executed. So that's what I mentioned before is path and tree of the YAML file. So these are the commands that get executed. So it sources this, exports this, SSHs, creates Docker Compose on the SSH, so on the VM, and then that's all the nested Docker Compose file we talked about earlier. That's what happens there. I set up some environment variables to make this command a little bit easier and nicer. So that's why you have this set up. Again, I'm going to write a better README full details on how this the environment builds with your Docker Compose, but for now, think of it just as a blind box, like a black box, and just like think of it that it just nests all of those Docker Compose files and set up. So once I'm done with that, I've inspected and I'm good to go. I'm going to do without the P and V, which is preview verbose, and that is what is happening on the VM. So the deployer, if you look up this stuff, this Docker Compose is basically running the compose, so cloning. Because I asked for the correct GPU. I don't think so. Let's see. Okay. See how this goes. Yes, that's correct, I think. Let me double check. The Docker Compose books. Files view service. So this is my top level. Yep, that's correct. A top level Docker file. So this is my Docker file, and I am nesting this one and this one. So if you see, I am this one. So this is spoofed in those environment variables, but what it is just it extends that one, and that Azure one extends the base, which is what you get here, and that base, again, in the environment variables, I choose which one I extend here. Where those environment variables get set up. That is a longer discussion, but right now I currently have it configured as an environment bash file. So basically, and this is nested as well. Get into the habit of doing this there. Let's see. Nope. There you go. Okay, so there you go. That's what I mean by this gets set up as Azure. So scenario files, I haven't talked about that. So it's personalized setup that I've chosen to. You guys can do it however you want with your Docker Compose. What I do here is what I do here in the deployer, you can see on my command line. So this deployer runs these bash scripts on your like its own environment, its command line environment. So what it does is sourcing the base environment scenario file, which is this one, and then it sources the .azure one, which is this one, and then it sources Azure, and then it sources the CPU one. So once it sources all three, you have all those environment variables set up in this bash session, and then basically all these following commands will see all the environment variables that are exported in these three commands. So again, you can do this all manually. The deployer script just automates this. So then what happens is this Docker Compose files, these are environment variables that it expects to see on the command line. So that's what these three files, these scenario files, they export environment variables that we want our Compose to use. The deployer specifics, so that's for Compose. I usually have it as a project name, Docker files, and then a sub-project name, and then your services where you're going to list your Docker files and your internal, your project-specific Docker Compose. There's that, and then what you have afterwards, so that's the Compose setup. It's your Ansible setup, that's in Robotbooks. And finally, the deployer one, while this is running, what happens here is I currently set it up like this. So as you saw in this setup, when I'm asking for this alias, what it's giving me is giving me Azure.cpu because it's on that level. It's not doing this one. And then it does .docker. So it does, which is in the compose. So let me see, it's vm.compose. So what happens here is extends this file, which is basically this compose file. And then I've listed here, and basically it would pretend what it would look like instead of this. It would just be like that. That's what you would imagine it being. But so we don't have that duplicated everywhere. It's extending it so you get the options of continuing the path on docker.image, which will get you the final leaves of the path, which will basically give you that to the finish off. So that will give you that. And obviously, because I set up here as SSH, it's going to happen. I might try to make a visualization of these paths and trees, maybe make it a bit more understandable. But right now, that's how we get that, and that image is basically running that. And I do that with different deployment setups. So here I have creating the shell. So this is the Docker Compose command. Again, I use a wrapper for this because we're nesting Docker Compose files. The scenario, so the stuff we're loading. And then we have a couple of Docker Compose specific commands. Again, all of this is in the Compose API. You don't have to use it if you don't want to, but the usefulness of this is we're not duplicating a lot of these commands. They basically can be used between, you don't need a specific GPU if you can just move some environment variables. So that it reduces the amount of duplication, so that's a really useful thing. So if you want, it's up to a nicer, a bigger version would be these three, and then you would have a similar kind of setup, but because we have more composes, we have more setups. We're going to want to have a lot more complicated stuff, and then different UGVs for different stuff, but it's easy to add a new configuration. That's what's nice about Compose. And then obviously you can have the Kakin set up, which has all your Kakin, and because you're using Kakin tools, you can set up which Kakin profile you want specific for this deployment. Cool, so that looks like it built. The CPU VM is pretty small. So the Docker image is pretty small, so that's why I was able to finish really quickly. The GPU one is a lot larger. The GPU one, you'll probably get cut off by VPN, so please be careful on that. And just to show you, just to hurry because we only have a couple of minutes left. There we go. We have our images set up, and now I want to create a container. I'm going to call shell. That creates my container for me. Okay. Cool. So now I have my container on the VM, and then we have a couple of handy tools in the infrastructure. Docker join, which is going to start basically going past through stuff. So please use that. Cool. So now, if you see, I'm on the Docker container. It has a different user, so that's how you know. And then now that we have the container up and running, I'm going to do a pretend Kakin build, which is not a Kakin build. Nothing happens. I just have I don't have a Kakin workspace anywhere. So what it does, you can double check with those sources things, sources, SSHs into that, enters a Docker container, and then just executes these commands in the containers. I'm going to do that. So you'll see. There you go. That's the output. This is the whole output of the deploy. You see, you definitely got into the container because the container name, the username is developer, and the host name is not. So that's how we know we're inside. So if I want to do something nice, I can do that. And just another quick thing. So one last thing before we finish is, let's say, how do we update the VM with new changes? So I make a change. Let's say ls. Oh, I want to do that instead. So there's a tool with a deployer called transfer2. So it's a little tricky, as in it doesn't it's basically an rsync between your local host and the VM. And so that did a transfer2, and then I'm going to build. There we go, and that's going to build for me. There we go. The ls all happens. So I use the transfer2 a lot. The only problem with transfer2 is if you have a huge workspace, so like subT, this can take a long time. So in the scenario files, that's where all the Docker setup lives, and some of the deployment as well. We have some, I believe, there we go. There are some rsync exclude options. I'm going to put this in the README. I put it in for subC, but I haven't gone over here yet. But you can exclude some folders to be transferred. So I don't really care about the Git folder on the VMs. I'm not pushing from the VMs. My development cycle is I work on the local host, and then I push to the VMs, and then with transfer2, and I only commit from my local host. I don't want to get too, because I'm going to get too confused really quickly, and I don't want to do that. So it's kind of like Git. You have one place, and you push through your remotes. So for me, this is my practice. You don't have to do the same. That's just another tidbit, and you can do this for the GPU if you have that one. Just change that, or docker.image, which is pretty nice, and then that's some advantage to the deployer. If you keep the aliases the same, it's kind of easy to go through the different ones, and you can always run them in parallel. I tend to run tmux with the core in parallel, and that is it. What's the tutorial? I think I'm done. That is 6 o'clock. So yeah, that's finished. We're done. It just goes over everything here. Please let me know. There's a lot more things on the Jenkins stuff. There's so much. I kind of wrote a bit more. You can go through all the tutorials, Jenkins, and then tools, and then some modules, and more questions and concerns. Please keep watching this. Use this if you want. Let me know feedback. But yeah, I am done with the tutorial.